Hello everyone and welcome back to another video. So in this video we will see about ArgoCD. So we will see what is ArgoCD, how it solves the problem of continuous deployment in Kubernetes applications, right? And we will see what are the different components of ArgoCD and how that components works with our Kubernetes cluster, how we can install ArgoCD, right? So all those things we'll try to cover in this video, as well as we will do a demo of ArgoCD, right? So I'll create an EKS cluster in one of my AWS account, and from there we'll install ArgoCD, and from ArgoCD we'll try to install an application in our EKS cluster, and we'll see how we can deploy an application using ArgoCD from Argo UI as well as in a declarative way. So all those things we'll try to cover in this video. So yeah, let's get started with that. Okay, so the first thing that we will cover here is what is ArgoCD. So ArgoCD is basically a continuous deployment tool for our Kubernetes applications. So when we create an CI/CD pipeline for our Kubernetes application, so the CI part can be managed by Jenkins or any other CI tools, right? Where we can build our Docker images and we can push those Docker images to any Docker registry, whether it's Docker Hub or ECR registry. That's fine. The CD part is a bit challenging, like how we can deploy those new Docker images or new updates to our application in a Kubernetes cluster, right? So here comes the ArgoCD, which takes care of all the deployment related things in our application, right? So it can also roll back if the application fails to start, if there's any issue with that application or with the new Docker images or the new changes. It can also roll back to the previous version. So it maintains the versions as well of our applications, right? And apart from that, there are multiple features from ArgoCD, like automate deployments of application to specific target environments, which means we can use multiple EKS clusters or multiple Kubernetes clusters managed from single ArgoCD, right? So a single ArgoCD can manage multiple Kubernetes clusters where we can deploy our applications. We can decide which application needs to be deployed on which Kubernetes cluster, right? And it supports multiple configuration management like customize Helm, JSONnet, plain YAML. Right? It can also be integrated with SSO or OIDC authentication. So there are multiple things with ArgoCD. So these are a list of features that it provides. Okay, so the next important thing that we need to discuss about is GitOps, because ArgoCD follows the practices of GitOps. So it's more important to understand what it is, right? So it's nothing but a combination of two birds. One is Git and other is Ops. So all the operations related things that we used to perform with our infra or with our applications, all those things needs to be in Git. So whether we are provisioning a new infra using Terraform, or whether we are managing our applications in Kubernetes cluster using manifest files or using Helm charts. So all those things needs to be in Git, where Git works as a single source of truth, right? So if we made any changes to our Git repository in main branch or in any feature branch, so usually we used to prefer main branch only, not the feature branch. So let's consider we have a main branch in Git and we have made some changes to that main branch. So those changes should be reflected in our infra or in our application, right? So that's what GitOps is. So what benefit we are getting out of it? So the first benefit is manageability. Like we can easily manage our infrastructures or our applications if we have a single point where we have all our code base, right? We can make changes to that code, and that will be simply reflected to our application or our infrastructures. And the other thing is trackability. We can easily track the changes, who have made the changes, what's the purpose of those changes. So we can track all the changes that have been made to our applications or to the infrastructures, right? So these are the benefits that we are getting out of it, right? And ArgoCD also follows the practices of GitOps. So all the application changes that we used to perform with our Kubernetes, all the application manifest files, whether it's Helm charts or the manifest files in written in YAML, needs to be in Git, and ArgoCD will only fetch the changes from Git. So let's suppose we have a ArgoCD running here. So ArgoCD, so the single source of truth for ArgoCD would be Git. So it will be connected to this particular Git repository. Any changes to any specific branch made to this Git repository will be fetched by ArgoCD, and ArgoCD will perform those changes in our infrastructures in Kubernetes, right? So this is how ArgoCD follows the process of GitOps. and this is how ArgoCD makes the changes in our Kubernetes applications, right? Okay, so now let's see what are the different components of ArgoCD. So these are the components that you can see on the right side. So there are four stages of these components. One is the UI stage, then application stage, then the core stage, and then the infra stage. So in UI stage, as you can see, there's web and CLI. So this is basically the UI interface where you can interact with ArgoCD. So it's basically interacting with the API servers. So to interact with the API server of ArgoCD, we need to have some UI or some CLI commands. So from where we can communicate to ArgoCD. So that's where the UI sits, and that's the application layer where the API server of ArgoCD sits, right? The other core components are most important things for the ArgoCD. So one is the application controller. So what is application controller? So when we deploy an ArgoCD, so we used to create projects, and inside the projects we used to create applications. So those applications are the Kubernetes objects that we used to deploy in Kubernetes, right? So in ArgoCD we used to create applications for them. So all those applications that we used to create in ArgoCD, all those applications will be managed by application controller. So this application controller will take care of all the changes made to the Git repository for that particular application. If there's any changes detected, so this application controller will sync those changes to the Kubernetes, right, inside the Kubernetes where our actual application is running. So it will make sure that the changes made in to the Git repositories will be in sync with the actual deployment in our Kubernetes cluster. Okay, so the next important component is application set controller. So application set controller is basically used when we have multiple applications and we want to deploy those applications in different Kubernetes clusters, right? For example, we have a dev application and we want to deploy that dev application into dev Kubernetes cluster. And similarly, we have a prod application and we want to deploy that prod application to prod Kubernetes cluster, right? So similarly, let's suppose we have multiple applications and multiple Kubernetes clusters. So in that case, what we will have to do, we will have to create different applications in ArgoCD, and we'll have to assign all those applications with specific Kubernetes clusters, right? So in that case, we'll have to manage multiple applications. So instead of managing those multiple applications, what we can do, we can create application set controller. So as you can see here, this is how we can create application set controller in Kubernetes. So it's a kind of application set, and this is the API version that we can use. So here, as you can see, we are creating a generator, and inside the generator we are creating a list, and inside that list we are creating that elements. So inside these elements we are creating cluster. So we are defining the cluster. So the first cluster would be engineering dev, and we are defining the URL for that cluster. So this would be the API URL for that specific cluster. So let's suppose it's 1.3.1.2.3.4. Similarly, we are defining other Kubernetes clusters as well. So the same way here, as you can see, we have defined engineering prod and finance pre-prod cluster with the specific API URLs, right? So now, as you can see here, it's the template that is being defined in this particular application set. So this template is again an application of ArgoCD. So you can take an example of a deployment in Kubernetes. When we create a deployment in Kubernetes, we used to define a template for pod, right? When we create a deployment, so inside the template we can define multiple pods. So similarly, in application set, we used to define the kind of application set, but inside this application set, we can define a template, and this template is again a application of ArgoCD. So inside this application, inside this template, we have defined these variables that we have defined in generator. So we have called these variables here. So it would be like the dot cluster and then the hyphen guest book. So what this will do, this application set will create three different applications for these three clusters, right? So for engineering dev, so the first variable, it will pick engineering dev, and that engineering dev will be placed here. So it will be, so the application will be created engineering hyphen dev hyphen guest book, and that will be deployed to the URL of this particular cluster, right? And then there comes a repo server. So repo server is basically used to connect with our Git repositories. So when we connect our ArgoCD with the Git repository, so repo server is responsible for that. It used to manage the credentials for that Git repositories. It used to fetch the Git repository changes. All those things will be taken care by repo server. And then there are the infra components which are like Redis is to manage the sessions or any key value pair that Argo CD will require to store, so that will be stored in Redis. Then Kube API is basically the Kubernetes API, that the master Kubernetes API that's deployed by and managed by EKS. So that is something which Argo CD needs to communicate with. So that's not the component of Argo CD, but that's the required component for Argo CD, right? It needs the Kubernetes API. Then Git is something which Argo CD needs to connect with, right? So Git is also not the part of the Kubernetes, not the part of the Argo CD, but it's something a required component by Argo CD. And then here comes the DEX. So DEX is basically responsible for the authentication of Argo CD. So for example, we want to deploy OIDC authentication for our Argo CD or LDAP authentication. So we can do that by DEX. So DEX is responsible for that OIDC configuration for that Argo CD, right? So these are the different components of Argo CD. Okay, so let's take a look at the demo of Argo CD. So what I'll do is I'll spin up some resources in AWS. So I'll spin up a VPC and EKS cluster. And once that EKS cluster is available, we'll access that EKS cluster and we'll try to install Argo CD there. And with the help of Argo CD, we'll deploy application in EKS cluster, right? So what I'll do is I have Terraform template written. So I'll just quickly apply these Terraform templates and it will spin up the resources. Terraform apply. Okay, so my AWS resources are provisioned. So I'll just quickly take a session to my Bastion instance, right? So I'll just copy this instance ID and in my terminal I'll type SSM and then instance ID. So I would be able to take a session of that particular instance and I'll do a sudo -ie here. And from here I'll just do kubectl get nodes. So as you can see, I'm able to see the number of nodes running in my Kubernetes cluster, which is in ready state. So I would be able to create and deploy application in this Kubernetes cluster. So to install Argo CD, what I'll do is I'll create a namespace. So kubectl create namespace Argo CD. So inside this namespace, I'll deploy Argo CD, right? And to do that, there's a command available, which is a kubectl command and a manifest file in YAML file, which is available and provided by Argo CD. So we can just simply run this command in our terminal to deploy Argo CD. So this is the one way, and the other way, if you want to use Argo CD Helm charts, like if you want to provision Argo CD using Terraform and you would like to have Helm charts there, so you can also leverage this. So these are the Helm charts provided by Argo CD. But for this demo purpose, I'll do this kubectl command, which is the simplest way to install Argo CD. I'll just copy this command here. I'll just copy. Yeah, I'll just copy this command here, and I'll just paste it in my Bastion instance. So it will deploy all the resources, all the components required by Argo CD. So it has created some CRDs, it has created service accounts, and some RBAC roles, cluster roles, role bindings, config map secrets, all those things it has created. So to verify, let's just quickly do kubectl get pods -namespace Argo CD. So as you can see, all of my pods are in running states. So these are the pods that we just discussed just few minutes back, like what are the components in Argo CD. So this is the DEX server running, this is application set controller, application controller, Redis, repo server, Argo CD server. So this Argo CD server consists of Argo UI as well as Argo APIs, right? So let's wait till. Okay, so now all the pods are in one-on-one state, so everything is up and running. So now the next thing is to access Argo CD. So how we would be able to access Argo CD? So for that, what we will do, we will just quickly look into the services of Argo CD. So if we'll take a look into the services, so these are the services. So among these services, this is the service that we need to expose over the internet, so that we would be able to access the UI of that Argo CD. So what I'll do is, as of now, the service type is cluster IP. What I'll do is I'll just change the type from cluster IP to load balancer. So it will spin up a load balancer in my AWS account, and from that load balancer endpoint, I would be able to access Argo CD UI. So what I'll do is I'll just quickly kubectl edit service, and then I'll give the service name in namespace ArgoCD. And at last, I'll just change the type to load balancer. Right, so it has been changed. And if I'll just quickly do the get command, so as you can see, the ArgoCD server, this particular service is exposed as a load balancer, and this is the load balancer endpoint. So I should be able to access ArgoCD in just couple of minutes. So let's just wait 1 minute, and then we'll try to access this endpoint. Okay, so as you can see, I'm able to access that particular endpoint, and I'm able to access the ArgoCD UI. So from here, I'll just quickly log into here. So the default username would be admin, but the default password is not admin. So we'll have to fetch the password. So what ArgoCD does is it stores the admin password in a secret and will help to decode that password from that secret. So if I'll do kubectl get secrets in namespace ArgoCD, so you can see here's a secret, which is ArgoCD initial admin secret. So we'll have to decode the secret from here. So what I'll do is kubectl get secret and then name of the secret hyphen namespace ArgoCD, and I'll just do an output in YAML file in a YAML format. Sorry. So this is the password which is base 64 encoded, right? So I'll just quickly decode this one. So I'll just do a echo, and in pipeline I'll do base 64-D. So -D is for the decode. So this is the password for the admin user. So I'll just copy this password and I'll just paste it here. If I'll do sign in, so as you can see, I'm able to log into my ArgoCD, and I would be able to create applications here, right? Okay, so now it's time to deploy our first application in ArgoCD, using ArgoCD in our Kubernetes cluster. So what I'll do is I'll just deploy this application. This is a SOAP application, which is provided by ArgoCD. So what I have done is I have cloned that application from ArgoCD repository to my personal GitHub repository. And from here, what I'll do is I'll just quickly deploy this application using ArgoCD. So to do that, the first thing that we require is the credentials, so that the ArgoCD would be able to access my GitHub and would be able to clone and fetch the changes from my GitHub repositories, right? So to do that, what I'll do is I'll just go to the settings, and from here I'll just connect to a repository. So I'll just select this one and I'll just do a connect repo. So the connection method would be SSH in my case, because I'll use an SSH key pair here instead of HTTPS authentication. I prefer SSH every time. So what I'll do is I'll select SSH here, and I'll give a name here. So let me give it a name of the application, and the project as of now I'll just keep the default, but you would be able to create new projects if you have a number of projects and you would like to keep in a structured way. So you can create multiple projects, and in each project you would be able to deploy applications. So as of now I'll just use this default project, and in repository URL I'll just quickly copy the SSH clone URL here, and I'll just paste it here. And in SSH private key I'll just quickly create an SSH key pair, and I'll just quickly attach that. So over here I'll just quickly do SSH hyphen keygen hyphen type RSA hyphen C. I'll give it a name like ArgoCD, okay, hyphen capital C, right? So this will create a key pair. I'll store it in the same location. So I'll do a /ArgoCD. Okay, and here as you can see I have a key pair created here. So I'll just quickly copy the private key from here. So this is the private key, and this private key will have to paste it in ArgoCD so that ArgoCD would be able to authenticate, and at the same time we'll have to copy the public key in our GitHub repository. So I'll just copy the public key from here. I'll copy it, and in my GitHub repository I'll just quickly go to my settings, and from here SSH I'll just create a new key pair here. I'll give it a name ArgoCD, and I'll paste the content. Okay, so as you can see I am able to add my ArgoCD, the public key pair, in my GitHub repository. And from my ArgoCD console what I'll do is I'll just quickly save the settings. So I'll just quickly connect it, And over here you would be able to see this successful. So if you ArgoCD is able to connect to your GitHub repository or to your Git repository, you should be able to see successful here, right? So that means I'm successfully able to connect to my GitHub repository. Okay, so let us create a new application using ArgoCD. So what I'll do is I'll just create a new app here. I'll give it a name. So I'll give it a sock shop, and from project I'll select the default project, and from sync policy I'll do a automatic. And from here, when we select an automatic, we would be able to see there are two checkbox enabled. So we will enable these two checkbox and we'll see what this checkbox means. So prune resources means if the resources are deleted from the Git repositories, so ArgoCD will also delete those resources from our Kubernetes cluster, right? And self-heal means if a deviation in cluster is detected. For example, if someone have made any changes in our application manually in Kubernetes cluster, and ArgoCD will detect those changes and will revert those changes. So everything that is defined in Git will be the final state in our Kubernetes cluster for those application. So any manual changes, if done in our Kubernetes application, so those will be reverted by ArgoCD. It will maintain the state which is defined in Git. So these two checkbox we will enable here, but depending on your requirement, you would be able to remove any of this checkbox. And from here, I'll select auto create namespace. If the namespace is not found in our Kubernetes cluster, so ArgoCD will create a new namespace for us. And from repository URL, I would be able to see the repository that we just connected in our ArgoCD. So I'll select that repository. From revision, I'll select head here, and in path I'll do a dot. So if you'll see here in my Git repository, so there's a customized file created in that particular repository, right? So that file will be used to deploy our application, and inside this customized file we have defined resources, and we have defined all the resources in our base directory. So it will deploy all these YAML files, right? So that's why I have selected dot here. So that will pick up the customized .yaml file. And from cluster URL, we would be able to see the default cluster here, which is the default cluster where ArgoCD is installed. But if you have multiple Kubernetes clusters, you would be able to manage that as well. So you have an option to attach multiple Kubernetes cluster with a single ArgoCD, right? So from here, you would be able to see multiple Kubernetes cluster if you have. So you can select that Kubernetes cluster from here. And in namespace, I'll do sock. So this namespace will be created because I have selected this auto create namespace option here. So if this namespace is not available in Kubernetes cluster, so this will be created. And from here, customize, there are some variables. So in namespace, I'll just do sock here again. And I'll not change any of these variables. I'll just keep everything default. And I'll just quickly create this application. So it may take not more than 1 minute, but let's just wait till this application comes up. So what I'll do is I'll just do a watch command from my terminal to see if everything is getting created properly or not. So what I'll do is kubectl get namespace. So as you can see, this namespace is created. So I'll do watch kubectl get pods -namespace. So yeah, let's wait till all the pods are up and running, and we'll try to access this application, right? So as you can see, most of our pods are in healthy state, are in running state, and there's one front-end pod is also in running state. So what we'll do is we'll try to access this front-end pod. So what I'll do is I'll just change the service type to load balancer, so I would be able to access that particular service publicly. So what I'll do is kubectl get services in sock namespace, and okay, so the front end is already in that load balancer cluster type, so load balancer service type, so I don't have to change anything here. So what I'll do is I'll just copy the endpoint and I'll just try to access it over here. So I should be able to see my application up and running here. So let's wait. Okay, I continue to the site. Okay, so yeah, as you can see, the application is up and running. So this is one way to deploy our application using ArgoCD, using ArgoCD UI. But the same thing can be done in a declarative way, where we would be able to create YAML files for these ArgoCD applications, and we would be able to deploy our applications in a declarative way. So let me show you how we can do that as well. So first I'll just delete this application that I have deployed using ArgoCD UI. So I'll just quickly delete this one, and I'll just give a confirmation here. Okay, so this application will be deleted from ArgoCD UI. So the same application I'll deploy in a declarative way, right? So to create an application in a declarative way, what I have done is I have created an application.yaml file here. So if I'll open this application.yaml file, so as you can see, I have selected the API version and argo project.io/v1 alpha 1. So this is the API version, and the kind of this particular application is application because this is going to be an ArgoCD application, and this ArgoCD application will be created in ArgoCD namespace because this application is part of the ArgoCD, right? So that's why we are creating this application in ArgoCD, but the application, the actual application that we are going to deploy in Kubernetes, that is going to be in SOC namespace. So that we have defined here, right? This namespace is different. This is the namespace of ArgoCD application where the ArgoCD application will be deployed, and this is the namespace where our application will be deployed that we are deploying using ArgoCD. So both are different, right? So this is we have defined. So this is the specification of that ArgoCD application. So in project we have selected the default. In repo URL I have given my repo URL, the SSH URL for my repository, and the same configuration we have defined here, the same configuration that we have defined using ArgoCD UI, right? So I'll just quickly save this file, and what I'll do is I'll just quickly do a kubectl get application in ArgoCD namespace. So as we can see here, we don't have any application deployed as of now, and I'll just quickly deploy this application kubectl apply -f application.yaml, and I'll just do an enter. So as you can see in ArgoCD UI, this application that we just deployed using declarative way just came up to the UI. We would be able to see that application here, and if I do kubectl get application in ArgoCD namespace, so I should be able to see that application status and everything, right? So this is how we can use ArgoCD in a declarative way as well. And if you do kubectl get pods in SOC namespace, so I should be able to see all the pods up and running in my SOC namespace. And if I'll delete this application using my kubectl command, so if I'll do kubectl delete application, the application name from ArgoCD namespace, so I would be able to delete this application from ArgoCD as well. Okay, so this is all what I need to discuss about ArgoCD. So now it's time to delete all the resources that I have created in my AWS account. So one by one, I'll delete all those resources.